Question number 3 says, two spheres have their surface areas measuring 72 cm squared and 50 cm squared. We are now asked to calculate A, the ratio of their radii, B, the ratio of their volumes. This area R, radii times 2. That is what gave you area, or that's what gave you the square you saw in their units. Now, the ratios now are, let's say, 72 and 50. This is cm squared. This is also cm squared. What we're going to do now, since they are requiring their ratio in the ratio of their radii, you must reduce this to a square root. Reduce 72 and 50 to a lowest term or a low term that is a perfect square that you can find its square root. If you divide 72 by 2, 2 divides 7 will give you 3. Remainder 1. Divide 12 will give you 6. This is a perfect squared number because 36 has the square root being 6. All over, if 2 also divide 50, you have 25, which also is a perfect squared number that has a single number that is its square root, and that is 5. So it now means that what you have here is the square root of 36 is 6. That means it is 6 squared. 36 is 6 squared. And 25 is 5 squared. Now that you have squared, or you have a number that is squared, that is equivalent to the values of the area the equation gave you, you can now use those numbers and forget about their squares. That means now that in question number A, the required ratio of radii, is now equal to 6:5. Question number B is linked up to question number A. Question number B said that we should also calculate the ratio of their volume. Now that you have discovered the ratio of their radii, just multiply each one by 3. It will give you the ratio of the volume. So if ratio of the radii are 6:5, that means ratio of their volume is going to be 6 times 6 times 6 is to 5 times 5 times 5. 6 times 6 is 36. Then 36 times 6 will give you 216. Is to 5 times 5 is 25 times 5 will give you 125. So now this is the ratio of their volumes as the question has asked us to calculate. Question number 4 says, assuming the area of a circle of radius xcm is ycm squared, calculate the area of another similar circle whose radius is 3xcm in terms of y. The radius of the first circle is x. That means pi r squared, which is the formula for area of a circle, is now changed to pi x squared because radius r is x and it is equal to ycm squared. For the similar circle, the radius was given to be 3x. That means its area is supposed to have been calculated by the same pi r squared, which is the formula for area of a circle. But now that its radius has been given to be 3x, that means its area will be calculated by pi 3x squared. And if pi x squared is equal to y, cm squared as the equation has given, then what is going to be pi 3x squared? By direct proportion, you find out that it's going to be pi 3x squared divided by pi x squared times y all over 1. What this means is that pi times 3 squared times x squared, that's the meaning of pi 3x squared, all over, already you have pi times x squared in the denominator. Now times y all over 1. Remember, is equal to pi 3x squared. So you can cancel this, can cancel pi and pi up and down. You'll be left with 3 squared times y. Like 3 squared all over 1 now times y all over 1. That is what pi 3x squared is. If you join together this, multiplying out the numerators and denominators together, you're going to discover that it's going to be 3 squared is 9 times y will give you 9y. That means in terms of y, the area of that similar circle whose radius is 3x is 9y. On a map, a square field has a perimeter of 8 centimeters. If the area of the field is 10,000 meters squared on land, what does 1 cm on map represent on land? Inside the map, the square has its perimeter distance round it, measuring 8 centimeters. If the perimeter of a square is 8 centimeters, that means one side of the square will be 8 divided by 4, because perimeter is distance around the square. If 8 centimeters is perimeter, that means one side is perimeter of square. One side of the square will be 8 divided by 4, which is 2 centimeters. Likewise, if the area of the square is 10,000, if 10,000 meters squared is the area of a square, it means the square root of 10,000 is one side of the square. You know now, the area of a square is the product of two of each sides, or one of each sides squared. Then if it is one of each side squared, that means one of the sides, the square root of the area is one of the sides. Now the square root of 10,000 is 100, which is going to be 100, because 100 times 100 will give you 10,000. That now means that 2 cm on map represents 100 meters on land. But the question asks, what does 1 cm on map represent on land? If 2 cm represents 10 meters, that means 1 cm will represent, or will be, 100 divided by 2 meters, and that is 50 meters. And that is the end of that question. Question number 6 says, the map of a community, maybe your community, was drawn, this should be, was drawn, not withdrawn. We did not remove it. Was drawn on a scale of 1:25,000. One inside map represents 25,000 outside the map on land. And the area was represented by 11.5 centimeters squared on map. We should calculate the actual area of the community in hectares. That means you have to calculate the actual area of the community is the actual area on land measurement when you remove it from paper. This scale, very important. If the scale is 1:25,000, that means the area factor is 1 squared is to 25,000 squared. That's what it means. It will still give you 1, because 1 times 1 is 1, is to, let's find 25,000 squared. 25,000 times 25, too much money. We have 625 million. 6 zeros. So this is the, what we call this is the area factor. While this is the scale factor. Because we are talking of area. Now, what it now means is that 1 square meter is in the paper is equivalent to 625 million square meters on ground. If 1 is 625 million, the harmony will be 11.5. That's what it means. 1 is represented by, or is equal to 625 million. Now 11.5 by direct proportion is going to be 11.5 times 625 million. Remember, this is a cm squared. Cm squared. So let's multiply out. 625 million times 11.5 is giving me 718,750,000. 1, 2, 3, 1, 2, 3, 1, 2, 3. Too much money. 7,187,500,000 centimeter squared. That's what it means. But the question says we should give this value in hectares. That will introduce us to measurements. 10,000 cm squared. 10,000 centimeter squared is equal to 1 meter squared. Then another 10,000 meter squared we give 1 hectare. That means 10,000 times 10,000 cm squared is 1 hectare. By simple arithmetic. 1, 2, 3, 4. 1, 2, 3, 4. Just write 1 and put 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 1, 2, 3. 100 million cm squared is 1 hectare. Therefore, 7,187,500,000 cm squared is going to be, just use 100 million to divide this. It will give you the number of centimeters of this in hectare. Just divide. You have 1, 2, 3, 4, 5, 6, 7, 8. Just reduce this. 1, 2, 3, 4, 5, 6, 7, 8. It will now be 71.875. Then 3, 1, 2, 3, 4, 5 decimal places. It's going to give you 71.875. All these 00 have no meaning. Hectares. So that community measures 71.875 hectares, whereas it measures 7,187,500,000 centimeter squares. This is question number 7, and it says from the figure below, this figure, the area of the bigger shaded segment, the biggest shaded segment is 36 cm squared, while that of the smaller segment is 16 cm squared. Then find the diameter of the smaller semicircle if that of the bigger semicircle is 39 centimeters. All these things, this is a semicircle, half of a circle. And this angle subtends these segments. From the information given there, you discover that if you want to calculate the area of the circles of which, or the area of the sectors of which these segments are found, the area of the sectors are calculated by theta over 360 times pi r squared for the bigger, and this for the bigger circle, and for the smaller circle it is the same theta over 360 times pi r squared for the smaller circle. And this area now for the bigger circle is given to be 36 centimeters squared, while that of the smaller circle is given to be 16 centimeters squared. So let's write 16 centimeters squared. In this manner, you can find out that theta is common. Theta over 360 and pi is common in both of them. If you remove it, you find out that for the bigger you have that r squared is 36 cm squared. And for the smaller, the same r squared is 16 cm squared. 16 cm squared. If you want to evaluate only r for the bigger, you find out that r for the bigger is going to be the square root of 36, which is 6. For the smaller, r is also going to be the square root of 16, which is 4. That means the ratio of the radii of the circles where these segments are found is 6:4. 6 for the bigger, 4 for the smaller. Now the question says that we should find the diameter of the smaller semicircle if that of the bigger semicircle is 39. It will now bring us to saying that if 6 cm brought about or is equal to 39, if 6 cm radius brought 39 cm diameter, that means that 4 cm radius by direct proportion will bring 4 all over 6 times 39. 4 over 6 times 39 all over 1 centimeter diameter. If you evaluate this, you will get the diameter that 4 cm or the smaller semicircle will give. 4 times 39 is equal to 156 divided by 6. 26. That means 4 cm will bring 26 cm diameter. And that has answered our question. When I said that theta over 360 and theta over 360 are the same thing, what it meant is that it was the same angle, this angle here, that subtends the arcs that created the big and the small segments from where the equation was drawn. That was why the theta we are the same thing. Whatever the value of theta is here, for instance, if we are to calculate the area of this circle, of which the bigger side here is part of, is the same thing that the theta in the second small circle or small semicircle is. And that was why I said that what you have here is the same thing as what you have here. And that was why we now had the power to cancel them in both cases. Question number 8 says that a cone has a base radius of 5 cm and height of 6 cm. Another cone has a base radius of 9.17 cm and height of 11 cm. We should calculate the ratio of the curved surface area of the two cones. Let's assume that this is the first cone. Don't mind my drawing, no. I'm not an artist, but I know how to represent informations. Okay, let's assume that these are the two cones. The first one has a radius of 5 cm. The radius is distance from here to here, or distance from here to here. So this one is 5 cm. Then height of 6 cm. So this place is 6 cm. The second one is a little bit bigger than the first one. They said its radius is 9.17. So here is 9.17. And the height is 11. All is cms. So these are the two cones. But the question said that we should calculate the ratio of the curved surface area of the two cones. Curved surface area of a cone is calculated from this formula, pi r l, where this L is the slant height, this side, the slant height, not the perpendicular height. This is the L. Now what we're going to do now is we're going to use Pythagoras theorem to find the values of L in the different cones. Now I use the corresponding sides in the two cones to calculate the ratio of the curved surface area of the two cones. Let's take the first one. This place is right angled. So with our Pythagoras theorem, we discover that L in each case is the hypotenuse, while the height and the radius constitute the other remaining two parts of the triangle. So we are going to have from the first one, the first cone, that L squared, which is the hypotenuse squared, is equal to 6 squared plus 5 squared. Then in the second cone, IRL is the area or the curved surface area of the second cone. We have that L squared in this case is equal to 11 squared, this side squared, plus 9.17 squared. Now let's simplify this. L squared is equal to 6 times 6 is 36. That is 6 squared. 5 times 5 is 25. That is 5 squared. In this case, our L squared, remember this is L squared, is going to be 11 times 11 is 121. You can confine with your calculator. Then 9.17 times 9.17. This one is giving me 84.1 in 1 decimal point. Now let's add. In this case, our L squared is going to be 36 plus 25. 36 plus 25. 61. In this case, our L squared is giving us 121 plus 84.1. 205.1. Now, in this case, now if you take the square root of both sides, you'll be left with only L on the left hand side of the equation, and on the right hand side you have 61, the square root of 61. Likewise here, you have L on the left hand side of the equation, and on the right hand side you have square root of 205.1. So let's find the square root of 205.1. Have L is equal to the square root of 61. 61 square root 7.81. That means our L here is 7.81. In this case, our L here is going to be square root of 205, giving us 14.32 in 2 decimal places also. So these are the values of the slant height of the 2 cones. Now that we have gotten the sides of the cone, now the ratio of the curved surface area is going to be the square of the corresponding sides. If you like, you take square of 6 is to square of 11, which is the perpendicular height. 6 squared is to 11 squared, or the square of the radius is to the square of the radius, which is 5 squared is to 9.17 squared, or the slant height that we calculated, which is 7.81 squared is to 14.32 squared. So in each case, whatever you get is going to be the ratio, and they are going to be synonymous to themselves. This ratio is equal to this ratio and is equal to this ratio. So this one will give us 36 is to 121, or 25 is to 9.17 times 9.17. 84.1, or 7.81 times 7.81. This one is giving us 60.996. Then is to 14.32 times 14.32 is giving us 205.1. In each case, this ratio is equal to this ratio and is equal to this ratio. And it is the ratio of the curved surface area of the two cones.